Alright, so in today's video, I'm going to be solving the equation 9 to the power of x is equal to 27. So, to solve this, I'm going to start off by rewriting this as 3 squared to the power of x is equal to 3 to the power of 3. And the reason I'm doing this is so both of these values can have the same base, which makes it much easier to solve. From here, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 2 to the power of x is equal to 3 to the power of 2x. So I get 3 to the power of 2x is equal to 3 to the power of 3. And this means that 2x is equal to 3 and x is equal to 3 over 2. Alright, so in this video, I'm going to be teaching you guys how to solve the equation 1 to the power of x is equal to 2. Now, I know what you may be thinking. 1 to the power of any number is itself 1. So how can 1 to the power of a number equal 2? Well, there is a method to solving this. So first off, let's take the natural log or ln on both sides. So I'm going to do ln 1 to the power of x is equal to ln 2. Now, if I have something in the form ln a to the power of b, I can move this exponent b to the front, so this can equal b times ln a. So in this case, I have ln 1 to the power of x, and I can move x to the front, so I get x times ln 1 is equal to ln 2. Now, ln of 1 is equal to 0. So I get x times 0 is equal to ln 2, meaning 0 is equal to ln 2. However, ln 2 is equal to 0.693, so this is false. So this method does not work, the usual method of solving exponential equations. Now what I'm going to do is use an important formula known as Euler's formula. So this formula states that if I have something in the form e to the power of I times theta, this is equal to cosine of theta plus I times sine of theta. And I know this may seem a little confusing right now, but let's walk through it. So what if theta is equal to 0? Then this means that I got e to the power of I times 0 is equal to cosine of 0 plus I times sine of 0. And cosine of 0 is equal to 1, and sine of 0 equal to 0. So I get theta is equal to 2k pi. Now, if this is true, then e to the power of I times 2k pi is equal to 1. So, because this statement is true, then doesn't this mean that our original equation was 1 to the power of x equals 2, and this is equal to 1. This number right here is equal to 1. So we can say that e to the power of I times 2k pi to the power of x is equal to 2. All I did was substitute in that for 1. Now, if we solve for this, we should get our variable x. So what I'm going to do is I'm going to do the same thing I did the first time. I'm going to take the ln, or natural log, on both sides. So now I get ln of e to the power of I times 2k pi to the power of x is equal to 2. Now, if I have something in the form ln a to the power of b, this is equal to b times ln a. So I can move x to the front, and this is going to equal x times ln e to the power of I times 2k pi, which is equal to 2. Sorry, ln of 2. Now from here, this is the same thing as I times 2k pi times x times ln e, because I can again use the natural logarithm formula and bring this to the front. And this is equal to ln of 2. And if you guys already know, ln of e is simply equal to 1. So now I get I times 2k pi times x is equal to ln of 2. Now if I divide both sides by I times 2k pi, these two cancel out, and I get x is equal to ln 2 over I times 2k pi. Now I'm going to multiply both sides by I over I, which is equal to 1. So now I get x is equal to ln 2 times I over I times 2k pi times I. And I times I is I squared, and I squared is equal to negative 1. So now I get x is equal to negative I times ln of 2 over 2k pi. So this is my answer to this equation. Alright, so in this video, I'm going to solve the problem 2 to the power of 22 minus 1. So, to solve this, what I'm first going to do is rewrite this as 2 to the power of 11 times 2 minus 1. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 11 times 2 is equal to 2 to the power of 11 to the power of 2 minus 1. Now 1 is the same thing as 1 squared. So now I have 2 to the power of 11 to the power of 2 minus 1 squared. Now the reason I did that and rewrote 1 as 1 squared is because now I can use the property a squared minus b squared is equal to a plus b times a minus b. So just to clarify, a is 2 to the power of 11 and b is 1. So now I get 2 to the power of 11 plus 1 times 2 to the power of 11 minus 1. Now what is 2 to the power of 11? Well, 2 to the power of 9 is 512. 2 to the power of 10 is going to be double of 2 to the power of 9, which is double of 512, which is 1024. So 2 to the power of 11 is double of 1024, which is 2048. So now I get 2048 plus 1 times 2048 minus 1. Now 2048 plus 1 is 2049, and 2048 minus 1 is 2047. So I get 2049 times 2047. And now, a simpler way of multiplying this, rather than the usual method of this way it takes way too long. So a much easier route is to rewrite this as 2000 plus 49 times 2000 plus 47. Now from here, I can simply distribute. So I have 2000 times 2000, which is 2000 squared, plus 2000 times 47, plus 49 times 2000, plus 49 times 47. Now 2000 squared is going to be 4 million, plus 47 times 2000 is 94,000, plus 49 times 2000 is 98,000, and finally 49 times 47 is 2,303. So now, by adding all these up, I get 4,194,000, because 94,000 plus 98,000 is 194,000, and then I have to add in the 2,303, so now I get 303 at the end.